Welcome to the first session of Business Maths, where we'll be looking at the introductory aspect of calculus. Here, the main focus is to look at what is called differentiation, or the introductory aspect of differentiation, which is also part of calculus. The goals of this session is that at the end, we should be able to understand what a function is, examples of functions in a business, in economics, differentiation of a function, how to differentiate a function, and then how to differentiate a function from the first principle. We're looking at the rules under differentiation: constant rule, the power rule, the two or more functions of the same variable, also known as the sum or difference rule. We'll look at the product rule, the quotient rule, the chain rule, which has to do with composite functions that are not easily to be differentiated. So we use what is called the chain rule. Right. Here on our next slide, we have what is called a derivative of a function, or how to find the differential of a given function. This diagram here illustrates or shows how the first principle formula was brought about, or how we came about the first principle form. So think about this. Even if you are finding the gradient of a line from our basic school, we'll say we'll need 2 points with 4 coordinates, right? So here we have our y-axis, we have our x-axis, right? So it's the same idea of finding the gradient of a line, but here under differentiation, the idea is that we are looking for the slope of a tangent line to a curve. Remember, differentiation is a mathematical principle that is used to find the gradient or slope of a curve, right? So you are finding the slope of a curve or the gradient of a curve. So we also need 2 points with 4 coordinates. So I would say that the 2 points we have here are point P and then point Q. The first point P has 2 coordinates, A and then f of A. F of A is a functional notation. It's just writing this same A you have here, right? So we have A and f of A. So I could say that this A here is my x1, this f of A is my y1, and then I have a second point here, which is Q. I have coordinates z and f of z. Z here is my x2, f of z here is my y2. So I have 2 points here, and then with coordinates 2 here, 2 here, so 4 coordinates. Then I can find the slope of a tangent line to a curve, right? So what we'll do next is that we'll draw a straight line through these 2 points that we have. So a straight line through the points P and then point Q, right? This straight line over here is what we call a secant line. So take note, a secant line is a line that connects 2 points. So as you can see from this diagram, we'll see that this straight line over here, which is called the secant line, is connecting points P and Q respectively. Right. And then looking at this area over here, we'll see we'll have a distance here, right? We could say there's a horizontal distance here from P to the next point Q, right? Where we say the area of intersection, right? Here, this is where they will intersect. So from P here, there's a straight line here, which is called the horizontal distance to meet the second point Q. So we call this straight line the horizontal distance. The distance from what? P to the next point Q. This straight line is called horizontal distance. So we have coordinates for this distance as A and Z, isn't it? So from A to Z is what we call H, or from Z to A is what we call H. H is our horizontal distance, the distance between the 2 points, right? So we can go ahead and find the slope of a tangent line to a curve. The slope of a line PQ is equal to the gradient, or the slope of PQ is equal to f of z minus f of A. Right, it is the same idea. So I could say this formula over here, right, is the same as changing y over changing x, where the change in y is what? y2 minus y1 over changing x is what? x2 minus x1. Here, y2 is f of z, and then y1 is f of A, all over x2 is what? Is your x2 is z, and then x1 is what? A. So that is the same idea you have here, right? That's the same idea you have here. And then the distance from z to a is what we call h, which is known as the horizontal distance. Take note that differentiation is a mathematical principle that is used to find the gradient or slope of a curve, right? Okay, so this is basically the idea or the formula of the first principle, right? We'll just change the alphabets or do some small changes here to get the final differentiation from first principle formula, right? So you can say that as scale moves along, isn't it? As scale moves along the curve towards P, Z approaches A, right? As scale here moves along the curve towards the point P here, you can say that Z here approaches what? A. That's what they are trying to say. This also means H approaches what? 0. Because when you have this, what's it called? When you have this, your graph over here, let's say a graph, right? The point 0 is here, right? So you can see that as this point Q moves along the curve to point P, this Z approaches A, or we can say H approaches what? 0, right? The slope of a tangent line at point A and then f of A is given as the limiting value of the slope. It simply means that this area here or this point P is the area of interest, right? That is going to help us to find the slope of this tangent line to the curve. Okay, so we need limits. Okay, so we say that to find the differential of any function or to find the derivative of any function, say 2x, or give any given function, we'll say that dy over dx is equal to the limit as z approaches a. Take note, z approaches a is the same as h, which is the horizontal distance. Our y2, which is what? F of z minus y1, which is f of a, all over x2, which is z minus x1, which is what? A. It is equal to the limit as h approaches 0, right? Because as z approaches a is the same as what? H approaching 0. Horizontal distance here approaching 0, 0.0 here. Okay. So f into bracket a plus h is simply from this, let's say this function we have here or this term we have here. We say that from z to a, right? From z to a here is equal to our h. So z minus a is equal to h. We can just do what is called a change of subject here, and then we'll make z the subject. So making z the subject, we say that let z be equal to what? A plus h, right? So here in this formula, the z is being replaced with what? Or is being substituted with what? A plus h. It's just a basic change of subject, right? Minus f of a all over h, right? So this is the actual or we'll say the final formula for the differential of any function using the first principle formula. So therefore, the concept of the slope of a curve is the geometric version of the concept of a derivative. It's just telling you that to find the slope of any curve or any line tangent to a curve, we will need what? These 2 points with 4 coordinates, right? To be able to find the slope or the gradient of the curve. Okay.